So in this video, we're going to find the relative extrema of a natural exponential function. So here we have the function f of x equals 2x e to the x, and we're asked to find the relative extrema of that function. So we'll take the function f of x equals 2x e to the x. We know that relative extrema are going to occur when either the derivative, the first derivative, is equal to 0, or when the first derivative is undefined. So the first step is going to be to take the derivative of f of x. So we want to find f prime of x, which is going to equal 2 times some stuff. And then what we're going to do is take the derivative of x times e to the x, and this is a product of two functions, so I'm going to need to use the product rule. So first I'm going to take the derivative of x, which is just 1, and multiply it by the second function, which is e to the x, plus, and then the product rule says now take the first function x and multiply it by the derivative of the second function, but the derivative of e to the x is just e to the x. And then I see that an e to the x shows up in each term, so I can factor an e to the x out using the distributive property, and that's going to leave me with 2 e to the x times 1 plus x, or x plus 1 because the order of addition doesn't matter. And then what I need to do is find out when does the derivative equal 0. And the key here is that e to the x never equals 0. E to the x cannot equal 0 for any value you plug in for x. It doesn't matter. So the only way for the first derivative to equal 0 is for the 1 plus x to equal 0. By the zero product property, if either of the two expressions equals, if the function equals 0 and we have a product of expressions, then one of the expressions needs to equal 0. At least one of the expressions need to equal 0. So in this case, we just need to say, hey, when does 1 plus x equal 0? And of course, that happens when x equals -1. So x equal -1 is the potential x location of either a relative minimum or a relative maximum. And what we need to determine next is whether it's a minimum or a max. So we can either apply the first derivative test, or we could apply the second derivative test to try to see what the concavity of the function is, and use concavity to make a determination as to whether we have a min or max. So for example, if we want to use the second derivative test, we would start with our derivative f prime equals 2 e to the x times 1 plus x. And then we would take and find the second derivative of f of x using the first derivative. So I'd get 2 times parentheses, and I'm going to use the product rule again. So the product rule says take the derivative of the first function, which is e to the x, and the derivative of e to the x is e to the x. Multiply the derivative of the first function by the second function, plus, now take the first function, which is e to the x, and multiply it by the derivative of the second function, but the derivative of 1 plus x is just 1. And then when I look at this, I see once again that the e to the x is showing up in each of the two terms and can be factored out using the distributive property, which will leave behind a 1 plus x plus 1 right here, or just 2 e to the x times x plus 2. So once I have the second derivative test says plug in the number that might be a location of a relative extrema, and then see if you get a positive or negative second derivative. So we plug in f double prime of -1 equals 2e to the -1 times -1 plus 2, which is just equal to 2 over e times -1 plus 2 is 1. So we just wind up with 2 over e, which is a positive number. It's a number that's, kind of close to 2/3. But the key is that we want to notice is that f double prime at -1 is greater than 0. So we can say because the second derivative evaluated at -1 is greater than 0, f of x is concave up at x equal -1. And remember, if we're concave up, then that's going to correspond to a relative minimum on the graph. So there is a relative minimum, min, of, and if you want to know what the minimum is, then you can just plug your -1 into the original function. A minimum of f evaluated at -1, which is just going to be 2 times -1 times e to the -1, which is just -2 over e. So there's a relative minimum of -2 over e at x equals -1. So there's the relative extrema of a function f of x.